Thank you for the introduction, Eric. Quick mic check. Am I audible at the end? Okay, perfect. Hi, everyone. Thank you for coming back to my talk. I suppose we all love Robyn so much that we speak twice here. Okay, so a quick introduction. In the mornings, I work as a software engineer at Bloomberg, and during the night, I maintain free and open source software, and one of them is Robyn. Now, speaking of Robyn, we come to the question, what is Robyn? Simply put, Robyn is a fast async Python web framework with a Rust runtime. But before we dive any further, I'd like to tell you a story, the Robyn story. So once upon a time, in the vibrant month of April 2021, there was a diligent university student named Sanskar. He was in the final year of his university and was supposed to submit a final year project. But like all other diligent university students, he spent all his time exploring Reddit. During that time, a major company decided to introduce and incorporate Rust into their projects. And Reddit was filled with memes about rewriting everything in Rust. And I was also working on a Flask project back then, and I had been constantly annoyed by the lack of async support. And scrolling Reddit, I finally got an idea. I asked myself, Sanskar, what would be cool if Flask would have async support? But what would be cooler? If it was written in Rust, by the way. And with that epiphany, the idea for Robyn was born. But we come to the most important question of the talk, why the name? Now, I thought to myself, if I take care of an entity called Robyn, I nurture it and allow it to grow, that automatically makes me Batman. So if I am not responding to your queries for some reason, just have a bad signal beside you, and it's my moral obligation to come to you. Now, since its inception, Robyn is hosted on GitHub, is licensed under BSD 2.0 clause, is currently released under version 0.31.0, has more than 2,600 stars on GitHub, more than 750,000 installs on PyPI, but most importantly, it's under active development. And over time, we have acquired some sponsors, and I'm really thankful for them. But most importantly, the project that was started as a single-person project in his room has more than 40 contributors, and I believe that's incredible. But I am absolutely certain that someone in the audience must have had this question. We have so many web frameworks. Why do we need another one? Before I answer this, I'd like to explain the reason myself, and I like to explain how I compare the existing frameworks that are available. So for me, the performance is important. Then comes the ease of use, then the scalability, then built-in features, extensibility, hacker or innovator friendliness. This is a term that I've coined myself. I'll explain it further. Then end-to-end app creation timeline, and most importantly, community. Now, if we select any framework in the market, we have to settle for some reason. For example, if the performance is high, then the ease of use suffers. If it is scalable enough, then the extensibility is not there. Or if the built-in features are present, it's too opinionated to be extensible. And I believe that we have forgotten about hacker friendliness or innovator friendliness in the frameworks. We talk about collaboration and how it would scale, but it is something that we do not talk about. Community is decent, thanks to you all. Community is actually very nice in most of the frameworks, and end-to-end app creation timeline is decent, but I believe it can be improved. And with Robyn, I'm trying to create a framework that excels in all of them. We're not there yet, but we'll get there eventually. So, simply put, Robyn can be called a fast async Python web framework with a Rust runtime. But a detailed view over it would be a high-performance, community-driven, and an innovator-friendly web framework. Now let's talk about performance. And for it, I will let the metrics do the talking. Robyn, according to Tech Empower, can serve over 1 million requests per minute, and we are only getting started. And let us have a look at the architecture to see why it is so much faster than all the other frameworks. For one, we have a Rust core. This is majority of what makes Robyn faster than all its competitors. This is a multi-threaded runtime backed by Tokio. This part allows us to bypass the Python guild and use real Unix threads, so providing us real concurrency. Then we have a worker event cycle that does all the dirty work for us. This part manages the runtime, passes all the instructions to the Rust code. This part also initializes the thread pool and routes all the incoming requests to the thread-safe router. And then when we start the application using the command python app.py, the Python code is converted to Rust objects. Then the multi-threaded router is populated. And then the incoming request hits the router. And depending on the type of request or the type of function that is to be executed, be it synchronous function, asynchronous function, it is dispatched. And finally, the response is sent back to the worker event cycle. So this is the multi-threaded architecture of Robyn. Pretty cool, right? Now, imagine it being way faster. So Robyn not only supports multi-threads, it also supports multiple workers. So you can have, not only you can use the threads that are available per processor, you can scale it also across the cores that are present in your PC. We have a shared TCP socket that is shared across the processes. So how you would configure that is you just specify the number of processes and the number of workers, and you're pretty much good to go. Now let's talk about the ease of use. I believe that if a framework or a tool is not easy to use, most of us wouldn't bother learning it, because as software engineers, I believe we solve so many hard problems, and if a framework is adding to it rather than subtracting from it, it is not a lot of fun to use that tool. So let us have a look at the traditional Python app lifecycle. Traditionally, we'd have a reverse proxy, something like Nginx or Caddy. Then we'd have a web server like ASGI, WSGI, or potentially RSGI at some point. And then we'd have a web framework like Flask, Django, FastAPI. And let us zoom into the web framework side of things. A quick question to the audience. How many of us know how to write a Flask application? Okay, 90% of the room. So it is precisely for that reason Robyn looks like this. I loved writing Flask, and I knew many people loved writing Flask too. I have added some changes and to make the development experience better, but in my opinion, this API is very nice and should be used till people get bored of it. But let us talk about something that was not a no-brainer, that sparked a lot of controversy when I launched Robyn, the web server side of things. So here you see a code of the web server gateway interface, or a WSGI. These, a quick history about them, these were created to set a standard. These allowed the framework developers to expose interfaces and the server developers to consume from those interfaces. So the collaboration between the framework developers and the server developers was very nice. The framework developers didn't have to worry about the HTTP execution, and the server developers didn't have to worry about the routing. However, these are pretty nice. Robyn doesn't require an SDI or doesn't need one. It comes with a server integrated. So whenever I tell this to anyone else, the usual response is, what about PEP 333? Or what about ASGI? My answer is that if you read the PEP carefully, it was created to make the collaboration between the frameworks and the server easier. But in Robyn, the server is integrated in Robyn itself. So you do not need to worry about that. All the dirty parts are handled by us. And this is also one of the reasons why Robyn is also faster than all the other frameworks that are available. So if you are deploying a Robyn app, you just need to configure a reverse proxy depending on whatever your org is or depending on what your preference is, and then the web server is coupled with Robyn. Now let's talk about scalability. I like to split the scalability into two parts. One is how much throughput can the framework handle as the traffic grows. And the second part is how would you structure your code as the project grows. So let's talk about performance at scale. We have already seen Robyn is very fast. You can just have a reverse proxy and it will handle over 1 million requests per minute on a regular PC. Let us talk about organization at scale. Robyn supports functional views as well as class views are work in progress, but functional views is something that I believe are not available in any other framework at this point. Functional views allow to structure all the codes that are of similar responsibilities under a closure pattern. And I think I usually like to do that, but the fact that I couldn't find it somewhere else was a bit annoying. And if your code base increases and it makes it harder for you to split your code, you can use routers. Routers are a common pattern now. So it is basically like a sub-Robyn app that you'd use in a separate file and then include it in the main file. Now, let us talk about the built-in features. I believe that the built-in features should be present in a proper way because they serve as a good solid foundation. And a solid foundation should be important. And also, if there are no nice built-in features, then I'd have to implement everything myself as a user. Then it kills the point of using a framework. So Robyn, by default, supports synchronous functions, supports asynchronous functions, directory serving, static file serving, URL routing or path parameters, middlewares, and application events. Okay, now let's talk to the spicy part of the framework, extensibility. It is something that is very close to my heart. I have been a person who has written a custom code editor for myself, so having the freedom to extend the tool is something that's very valuable for me. And for this reason, Robyn has a concept called extensions. So we provide first-class support for extensions, as well as the ability to override them, and also you can install them if you want to. It's not shipped by default. So for example, we support templating, and in templating, we support Jinja templates. So you can see, you can just pip install Robyn templating and import Jinja templates from there. However, if you do not want to use Jinja templates, we provide interfaces that you can override and consume into your Robyn app with the templating engine of your choice. And also, Robyn supports GraphQL. So should there be a case where you want to use a GraphQL application internally but have external REST endpoints, you can use Strawberry GraphQL with Robyn. So you just declare some types, Strawberry types in Robyn, declare a few routes, and you're good to go. Okay, now the built-in features are nice and extensions are also nice, but what makes Robyn hacker-friendly? Or what is the term hacker-friendliness? Hacker-friendliness basically means, in my opinion, the ability to create an app quickly. I am a very strong proponent of making web frameworks hacker-friendly because we are talking about how these big applications handle collaboration, how these big applications handle scale. However, we forget that these applications were created by one or two people over a weekend or caffeinating themselves, making MVPs. And the code might have been terrible in retrospect, but it is also a reason why these applications exist today. And for that, Robyn supports something called const requests. So what are const requests? Like we talked in the architecture, like a few slides back, I noticed that this part of the architecture was very GIL dependent. You had to always acquire the GIL, get the response, and then release the GIL again. However, for simple tasks like JSON payload serving or file serving or image serving or a simple string serving, you do not need to do that. So in Robyn, you just calculate the response once, store it in the multi-threaded router, and then the GIL dependence is eliminated completely. So this makes the serving way faster because for every subsequent request, you do not have to acquire and release a GIL. Some people like to call it caching, but there's no TTL. So in Robyn, we call it const requests. And finally, WebSockets. Some people may say that it's a built-in tool, but I also use WebSockets in terms of message queues when I'm prototyping a lot of things. So Robyn supports WebSockets by default, and you can use it basically like a sub-router. And finally, not needing to choose a server. In the server world, I believe that it introduces a paradox of choice. There's Ubicon, there's Starlet. No, Starlet is a framework, sorry. Gunicorn, and all the other servers that are available. So you do not need to choose any of that. You can just specify the number of workers and the processes, and you're good to go. Now, let's talk about the end-to-end app creation timeline. This term basically means the time required for you to start an application from scratch and get it up and running in the cloud or up and running somewhere. So for that, what you would do in Robyn, you'd either install it through pip or you'd install it through Conda. Then we have a feature called Robyn CLI. So in my opinion, backend development or web development at this point is not just adding some routes or adding business logic. Now we need to worry about configuring the Docker files, configuring the reverse proxy, and all the other things that allow the collaboration easier. So in Robyn CLI, you'd just type the command Robyn create, and it will ask you if you require a Docker image, if the type of web proxy, the type of reverse proxy that you want to use. So it will make the configuration for you, do the boilerplate part for you, and give you a basic hello world route so that you can extend the application yourself. So the part of worrying about the configuration files is eliminated. And finally, if you want to access the docs from the terminal itself without leaving the zone, you can do that. But at this point, it's just an online feature only, but in the future, we'll have docs available in the terminal. And finally, just running in production is as simple as specifying the number of workers and the number of processes. Okay. Now, let's talk about the community side of things. And for that, I will tell you another story, the community story. So the community started like how all the other amazing things start, with a post on Reddit. And then we had a Jitter channel because it was cool to talk with people who enjoyed using the project. Then we decided it wasn't as accessible, so we moved to Discord, which was a platform that everyone preferred. Now everything was nice come November 2022. And for me, in November 2022, life got a bit overwhelming because of my personal events. I was still devoting some time to Robyn, but I wasn't as active. However, to my notice, we still made progress. And I tried to see what has happened and how we were making progress because I was approving PRs. And I came to this realization that the community was growing at a steady rate. Many features were recommended by the community, and 60% of the past releases had some sort of community involvement. And the 4 out of the past 10 releases had no involvement from me at all, just a few PR merges. So for that reason, I believe that Robyn, being a single person project, doesn't do much justice. It's a community project and should be attributed like that. So Robyn will no longer be under my name. It will be under an organization called Sparkles. And this is the logo. And if you want to read more about it, you can go to github.com/sparkles. So yeah, it will not be an individual project anymore. Now let's talk about what lies in the future for Robyn. We obviously want to make it more faster, add some automatic documentation generation because it's a feature requested by community a lot, add some sort of runtime data validation, maybe with Pydantic, maybe with MessageSpec, and have auto-const requests, add some sort of ORM support, but still follow the extensibility philosophy, where it's still lean by default, but you can extend the ORMs that are you are basically not tied to the features that we implement. Add authentication and authorization. This will be hopefully done within this week. Improve WebSockets, transition the repos to Sparkle.org without breaking the CIs. Improve the documentation, because I believe that a framework is only as good as the documentation, and the documentation around it should be nice. And for that, I plan to create some video-based tutorials because not everyone likes to read documentation and everyone learns differently. And invest more pragmatic text-based applications. And finally, add more support. And I believe that we are in the year of 2023. Some sort of AI-based support on the documentation website will be nice and help the developers to focus more on shipping features rather than supporting. However, I also still feel that we are serving humans, so human-based support is important. So we will be expanding our community and dedicating some resources for that. So if you are interested for helping us out, join our Discord. We hold monthly community calls, and we'll have one next month. And here are some of the important links. It's hosted on GitHub at this point, is on PyPI. This is the website. These are the docs, and this is the Discord. So you can star Robyn, and you can ask me any questions that you may have. Thank you so much.
Thanks, Sanskar, for showing us Robyn. We have some questions. If you have any more questions, feel free to ask them via Slido or just raise your hand after the first round of questions. I'm happy to take them. The first question is, did you test the performance of Robyn against Granian or any other RSGI framework server combination?
Yes. So compared to all the other ASGI, Robyn is faster. And for RSGI, it's still under progress, so the performance is changing a lot. So we'll see how that works out. I haven't tested it against Granian, but I think it should be available on Tech Empowered.
All right, and the other question was, I've kind of seen it on the roadmap already, but it's still relevant. Have you ever considered auto-detecting const requests by analyzing the Python AST, or what are your plans for that?
Yes, okay. I think I forgot to mention that. Yes, so we plan to support automatic const requests. Yeah, so this will hopefully be done in the future, but I don't know at what point, but definitely within this year.
All right. Any more questions?
Hi. So nice talk, and it's
Thank
very
you.
interesting. My question, though, is why Prisma instead of SQL Alchemy? I mean, Prisma is, it's open source, but it's from a proprietary company. So just curious.
That's a good question. It's just because I liked using Prisma by default, but we won't be enforcing that and shipping by default. It will be an extension. So we usually also support multiple extensions. So we will support SQL Alchemy as well. But Prisma was something that when I wrote the slides, I really liked using. So that's just one reason.
All right, any more questions? Great, then thanks again, Sanskar.
Cool,
And
thank you so much.